Howdy, this is Jeff Bowen. Welcome back to another video on linear systems. Today we're going to be looking at a linear inequality word problem. You can find a copy of the problem linked below. I'm going to read it. Here we go. Allie will donate up to $500 to charity. The money will be divided between two charities, the City Youth Fund and the Educational Growth Foundation. Allie would like the amount donated to the Educational Growth Foundation to be at least twice the amount donated to the City Youth Fund. Let X denote the amount of money in dollars donated to the City Youth Fund, and let Y denote the amount of money in dollars donated to the Educational Growth Foundation. Shade in the region corresponding to all values of X and Y that satisfy these requirements. Let's get started. Looking at the first part of the problem, Allie will donate up to $500 to the charity. Reading that indicates to me that Allie will donate less than or equal to $500 to the charity. She's not going to donate any more than this. She's going to donate $500 or less to the charity. Let's skip ahead in rereading this problem. I just want to make sure we note this. Let X denote the amount of money in dollars donated to the City Youth Fund. So X is going to correspond to our City Youth Fund. And Y is going to correspond to the following: the Educational Growth Foundation. Educational Growth Foundation. Okay, so the money will be divided between the two charities. We have our first inequality already. X plus Y is less than or equal to 500. How did we come to that? Well, the amount of money, X, for the City Youth Foundation, plus Y, the Educational Growth Foundation, will not exceed $500. So if we donate $200 to the City Youth Fund, then we can donate up to $300 to the Educational Growth Foundation. X plus Y is less than or equal to 500. If you have any questions about that, please let me know. I'm going to move on. Next, this is a tricky one. Allie would like the amount donated to the Educational Growth Foundation to be at least twice the amount donated to the City Youth Fund. Alright, let's transform that statement into an equation, an inequality actually. So, would we say that if Allie would like to donate the amount donated to the Educational Growth Foundation to be at least twice the amount, well, we know we're going to have a 2 in here. 2 times what? Well, 2 times the amount donated to the City Youth Foundation is going to correspond somehow to Y. It says here she wants the amount donated to the Educational Growth Foundation to be at least twice. So 2 times the City Youth Foundation has to be greater than or equal to Y, the Educational Growth Foundation. Okay? 2 times the amount of money donated to the City Youth needs to be greater than or equal to the Educational Growth Foundation. We're almost there. Here's the next part of the problem that some people actually don't realize exists. We have the hardest part done. But there are actually 2 more systems that we need to throw in here. Can you see what they are? I'm going to let you think about that for a second while we go ahead and start graphing. Biggest things we're going to need to remember right now is that X plus Y is less than or equal to 500, and 2X is greater than or equal to Y. Okay, let's start graphing this. I'm going to set my graph up as such. We're going to go by 100s because the numbers we're dealing with here are rather large. Alright, now remembering our equations. X plus Y is less than or equal to 500, And yes, I understand that that probably looks a little bit like a G. Let's rewrite that. And our second equation, 2x is greater than or equal to y. Let's graph this. This first one here is pretty easy. If we plugged in 0 for x, an output would be 500 for y, so we have a point up here. And if we plugged in 500 for y, 0 would have to be the x value. Just plugged in 0 here, got 500 there, 500 here, got 0 there. Okay? Next, let's go ahead and throw a line down. There is our first line. It is solid because this inequality is less than or equal to. You can donate 500 to one and $0 to the other. I think that one of these foundations would probably be a little upset by that, but, well, that's not what we're going to worry about. Next equation, 2x is greater than or equal to y. Best way to graph this, let's just throw in a number for x, and a big one. Let's throw in 100. Okay, 2 times 100 is greater than or equal to y. That would mean that if x is 100 for this equation, then our output would have to be 2 times 100 is 200. Alright, move this over for you can see. 100, 200 is one of our outputs here. So on our graph, that's 100, 200. That is a point on this line here. Another point, a relatively easy one, is 0, 0. If you donate 0 here, you get 0 out. So that's another point right down there. And now we have our second line. We're almost done. We just need to set up those barriers for the equations. But, like I said, we're missing 2 inequalities here. Maybe now it should be more apparent to you. Let me put this down right here, negative 100. And let me put over here, negative 100. Would it make any sense in terms of this problem for you to donate negative $100 to one of these charities? No. In fact, donating negative money would be probably the equivalent of sending someone a bill for $100 and telling them to pay you. So it doesn't make sense for any of the information over here or any of the information down here to be a part of our answer. So the 2 inequalities that we're actually going to add are as such. X has to be greater than or equal to 0, and y also has to be greater than or equal to 0. X being greater than or equal to 0 and y greater than or equal to 0 correspond to 2 lines on the axis like this. Just a quick note, one of these is not a function. That's okay. Can you tell me which one it is? Okay, we're at the last step. Let's go ahead and take a look at x plus y is less than or equal to 500. That corresponded to this first line right here. Everything below this line, because it's less than or equal to, corresponds to a value in output that is acceptable. Next, 2x is greater than y. Well, that's this line here, and since we have a greater than or equal to, everything up here corresponds to something that is an acceptable value. We're almost done. We know that everything above this line is also an acceptable value, but only things that are in here. And likewise, this vertical line on the y-axis, everything to the right of that is also acceptable, which is everything once again in here. So I'm going to erase these because this isn't part of our solution set. And there you have it. That area right there. If we donate $100, we can donate $200. Everything in here corresponds to an acceptable list of values that can be donated to these charities. If you have any questions about that, anything you want me to review in extra, please let me know. Otherwise, have a great day. Thank you.